An electron, in figure below, moves at the speed of 54 meters per second through a magnetic field with a strength of 1.2 Tesla. The angle between the electron's velocity vector and the magnetic field is 90 degrees. Assume a value of electron's charge of negative 1.6 times 10 to the power of negative 19 coulomb. Part A, what is the magnitude of the magnetic force on the electron? Part B, use the right-hand rule to determine the direction of the magnetic force. Part C, calculate the gravitational force on the electron. The mass of electron is 9.11 times 10 to the power of negative 31 kilograms. And part D, what is the ratio of the gravitational force on the electron to the magnetic force on electron? So first of all, we need to find out the magnitude of magnetic force, part A, which we need to use this formula, F equals to B times V times Q times sine theta. B is given, which is 1.2. Velocity is given, which is 54 meters per second. Q is 1.6 times 10 to the power of negative 19. And sine theta is going to be 1. Why? Because the theta is going to be the angle between magnetic field and the velocity. So which are, since they are perpendicular, sine 90 degrees is going to be 1. So when you calculate it, that's going to give us 1.037 times 10 to the power of negative 17 Newton. That's going to be the magnitude of the magnetic force. Now what about the direction? We are dealing with the electron. So what we need to do, we need to have the thumb toward the velocity, which is going up, 4 fingers toward the magnetic field direction, which is going right, and then your palm is gonna show, the right hand's palm showing the into the page. But that can be applied only to positive charges. Now right now we are dealing with the negative charge, so it is gonna go on different direction that comes out of the page. So I'm gonna show it like this, or you can use your left hand rule. So I'm gonna write out of the page. Part C, it says calculate the gravitational force on the electron when the mass of electron is 9.11 times 10 to the power of negative 31. Gravitational force equals to m times g. M is 9.11 times 10 to the power of negative 31. The value of g, gravitational acceleration, 9.8 meters per second square. 9.11 times 10 to the power of negative 31 divided by 9.8. That's going to be 9.3 times 10 to the power of negative 32 Newton. I made a little mistake here. It's 8.9 times 10 to the power of negative 30. That's going to be the correct answer. 8.9 times 10 to the power of negative 30 is going to be the gravitational force. Now part D, it says what is the ratio of the gravitational force on the electron to the magnetic force on the electron? So gravitational force, Fg over Fm, magnetic force. Fg is 8.9 times 10 to the power of negative 30 Newton. Fm, magnetic force, which is 1.037 times 10 to the power of negative 17. The answer is going to be 8.6 times 10 to the power of negative 13. It means that the gravitational acceleration, gravitational force is much smaller than the magnetic force.